Hello everyone. In this tutorial, we shall discuss the problem of two drunk men. This is a random walk problem. So the picture is like this. So we have a 1D random walk, and let's say two men, drunk men. So their direction of movement is random. Okay. So they started from origin, let's say 0. And their properties of random walk are identical, that both take a forward step with probability p is equals to, let's say, 1/2, and a backward step with probability 1/2. So we are asking the question, and the step sizes are also equal, and they started at the same time. So that what is the probability that they must meet back at same location after n step? So they started from origin, and now we are asking that after n step what is the probability that they will meet. Okay, so how to proceed this? So let's say first person moves 2 step right, and the second person then have to move 2 step left to meet this. So for this, first person right step are 2, left step are 0, but for second person right steps are 0 and left are 2. Let's say if this person, first person, have moved 1 step right and 1 step left. 1 second. 1 step right and 1 step left, then it will move back to origin, and the same thing will has to follow by the second one to be here. So another, then again first and second, 1 1, then 1 1, and if you go on, if you will see that if for right for first random walker, if there are n step right, then for second random walker there are n minus, okay, let me denote by k, n minus k step left. So this will always follow if they have to meet. So obviously for one random walker, the probability to move k forward step is given by the binomial distribution. So let us write the probability of the first random walker to move k step forward is given by the binomial distribution, and this is nothing but nck p to the power k q to the power n minus k. Similarly, probability of the second random walker to move n minus k step forward will again be given by nc n minus k p to the power n minus k q to the power k. Okay, now since these two events are occurring independently, the properties of this doesn't affect the properties of this, but we are asking the question that what is the probability that they move in such a way that they will meet. So these are the conditions they have to follow, but the probabilities are independent of each other. They are not correlated. The two random walkers are not correlated. Okay, so the joint probability of occurring these two events simultaneously would be simply given by the product of these probabilities p1 and p2. Okay, so the joint probability of occurrence the above event will be p1 p2 will be given by p1 into p2, and this is nothing but n ck n minus k and p to the power n q to the power n. Okay, so this is the thing. Now PQ are 1 So we can write this. Let us expand this. So n, okay, we'll expand it later. n minus k 2 to the power minus n, because minus 2n actually, because both are half. 2 to the power minus 2n. Now let's simplify this product. So we shall use the identity that 2nck is actually given by the product, not nc, 2nck. Okay, so just first expand this term. What is this? One more thing is that this is for 1k, but there can be many combinations, many possible ways, or many so there are many ways, different k's will be there. Okay, so the first possibility is that it goes 2 step forward, then n minus 2 backward, then it may happen that it goes 2 step forward, 3 step backward, or n minus 2 step backward, and so on. So we have to sum over all k's to get the total probability that they will meet. So we have to sum over k. So sum over k. So what is this sum? Sum over k, nk, n minus k is equals to, this is like k is equals to 0 to n, of course. So nc0, n plus n1, n minus 1, so on, and again ncn and nc0. So this is our the total sum. Now let us use this identity. So the identity is like this: 2nn is equals to nc sum over k is equals to 0 to n, nck, and n minus k. Just let us prove it. So if you expand this quantity 1 plus x to the power 2n, so what is this expansion? So from the binomial polynomial or binomial expansion, you can see that this is nothing but n. So let us use capital N. Yeah. So nc0 x to the power 0, nc1 x to the power 1 plus nc2 x square, and so on. Okay, 2n cn x to the power n, and so on, 2n x to the power 2n. Okay, now if you multiply, so this can be equally written as this 1 plus x to the power n, 1 plus x to the power n. And now apply binomial distribution to each of these expansions. So what will you have? You will have nc0 plus nc1 x plus nc2 x square, and so on, ncn x to the power n. Now again there will be same thing here also, nc0 plus nc1 x to the power 1, and so on, ncn x to the power n. Now if you compare the power x to the power n from both sides, so this side, from this you will have 2n cn. Okay, so since these two are equal, 1 plus x to the power 2n and 1 plus x to the power n, 1 plus x to the power n, both are equal. So let us compare the power of x to the power n from both the sides. The power of x to the power n, from this side it will be coefficient will be 2ncn, and here the coefficient is simply, so if you multiply this with the last, you will have x to the power n. Then if you multiply this with let's say this term, and cn minus 1 x to the power n minus 1, then you will have again, so n1 n minus 1 to the power n, and so on, and lastly again this term multiply with the first, and cn and c0. So if you see, these kind of combinations will give x to the power n. So this is the sum which we were looking. So 0 to n ck n minus k, and what we found, that this is nothing but 2ncn. Okay, so now our problem is solved. So p1 p2 was actually this sum, k is equals to 0 to n ck n minus k 2 to the power minus n. So if you just substitute 2n 2 to the power minus n, so this is nothing but 2 factorial 2n factorial n factorial 1 over 2 to the power n. Okay, so this is our answer, that the total probability that they will meet from starting from origin, they will meet again back, is given by this probability. So this finishes our lecture, today's lecture of the two drunk men problem, and hopefully you have understood. So for now, thank you very much.